Assalamualaikum. This video will continue about chapter 6. Alright. So this last part of chapter 6, we will learn about how we can design our own transmitter or receivers based on single sideband system. So the single sideband system or signal can be generated by using a modulator. Okay, so you can actually choose what kind of modulator that you want to use in your system. So there are 4 modulators that most commonly used, especially in generating single sideband signals. Okay, so first is the balance ring modulator. This modulator mostly used in the double sideband suppressed carrier, and it will be used to remove one of the sidebands so that we can generate or can produce single sideband signal. Okay, and another second modulator is the FET, push-pull balance modulator. So FET is actually field effect transistor, push-pull balance modulator. And the third one is the balance bridge modulator. So this balance bridge modulator is actually quite similar what the balance ring modulator has, and it actually uses the same operation, but a little bit different in terms of the circuit or electronic component configuration inside these two modulators. So I will show you after this on the next slide the shape or the equivalent circuit of these modulators. And the last modulator that is very easy to use is what we call linear IC balance modulator. So this type of modulator is actually inside an IC, the integrated circuit, and we can have an IC to become a modulator and just connect the outer part of the IC to be with the other electronic components such as diode, resistor, capacitors, and all, so that we can have um, exactly what kind of frequency or other what call it, other things that we want from the signal. Okay, so these are the equivalent circuit of the of the modulator. So the balance ring modulator, if you see here, it actually uses what we call lattice structure. Okay, it's actually cross on the parallel circuit. Okay, and it uses 4 diodes, which the diode D3 and D4 will be in the lattice structure. For the balance ring modulator, if you see, actually almost similar. It's just that the diodes is actually arranged in this kind of configuration, just like a bridge. Okay, and for the FET, push-pull balance modulator, it's actually used FET, field effect transistors, all right, and rather than diodes, which has in the ring and bridge modulators. So this FET push-pull balance modulator produces only the sidebands at its output, and it can suppress the carrier signal on the SSB signal. Okay, so this I think this slide I didn't provide in my lecture notes, so you may refer to this and see if you can use it in designing your own transmitter based on single sideband system. Okay, so the IC balance modulator. So this is one example of using linear IC balance modulator. So the IC model or number is LM14696. Okay, and using this 14 pins IC, basically we can have what we call as a transmitter. All right, so we have the modulating signal input over here. All right, and then the carrier input over here. So the IC will modulate these two signals and produce an output which will be the single sideband signal, AM signal. Okay, so this IC has advantages, all right, such as it has excellent carrier suppression. It can suppress the carrier signal and produce single sideband suppressed carrier signal. It actually has adjustable gain. All right, we can tune the gain of the IC depending on what kind of component you connect to the IC. The balance input and outputs, all right, and also the high rejection ratio. Okay, so for the single sideband transmitter, all right, basically we have three methods in order to produce the output of single sideband signal. So the first one is called filter method. The second method is phase method, and lastly is the third method. So in the next slide, I will explain what is mean by filter method and phase method. Okay, for the filtering method, basically it uses a filter to remove the undesired sideband. We don't want the sideband on our AM signal. So we use the filter method and get rid of the sideband that we don't want on our signal. Okay, and then it use the balance modulators to suppress the unwanted carrier and then filter the unwanted sideband. So most common or widely used sideband filters is the quartz crystal filters. And why we want to use this kind of filter? Because the quartz crystal filters is very selective and it's quite cheap. Okay, so this will be the block diagram how the filtering method in producing SSB signal looks like. So we have the carrier, we have the modulating signal came from a microphone, all right, and we use a balance modulator to modulate these two signal and produce a double sideband AM signal. So we use a sideband filter under filtering method to produce the signal sideband signal. So in this sideband filter, we will choose which sideband we want to remove. Okay, we want to remove so that it will gone from the output signal on at the end of the sideband filter. So if you want only lower sideband on the output of your SSB signal, so you need to tune your filter so that it can eliminate the upper sideband. So most of probably you can use a high pass filter. A low pass filter so that you will allow for this one, you will allow only lower sidebands frequencies on the SSB. And if you want the upper sideband, you may use high pass filter. Okay, and amplifier to amplify the output of the output signal, which is the SSB signal, before it can be transmitted through the antenna. Okay. Right. Next is the phasing method. So phasing method it actually uses two balance modulators, and by combining these two balance modulators, basically we want to use different phase signals in order to produce a signal that has only one sideband. Okay, so what I mean is when we have Okay, this is the block diagram of phasing method. We use two balance modulators, 1 and 2 over here. Okay, this is our information signal and this is the carrier signal. So for the information signal, first we will inject into a balance modulator 1, okay, and then modulate with the carrier signal that have been shifted the phase of the carrier signal. All right, and it will produce A1. Another one more signal, the information signal will go through a phase shifter and produce a signal that will be injected into the balance modulator 2, and it will modulate with the carrier signal that haven't been shifted the phase and come out as signal A2. So this signal A2 and A1 will be combined to be the output signal. So one of the sideband will be eliminated during this procedure. Okay, that is how we have the phasing method done in order to get only one side of sideband. Okay, so this this is an example of how we can have single sideband suppressed carrier transmitter. All right, which this is the diagram. All right, and how we can get an element we try to separate the lower sideband and upper sideband based on filtering requirements. Okay, so this one is we try to use BPF, band pass filter, and we want to separate the lower sideband and also the upper sideband over here. So this one is the transmitter that uses band pass filter. Okay, this is independent sideband transmitter. In order to produce the single sideband under independent ISB, independent sideband signal. Okay, so so if we see over here for the independent sideband system, it uses, I think, more than 2 modulators. If you see over here, we see 1, 2, 3, and 4 modulators, as well as few filters. 1, 2, 3, 4 bandpass filters. So in each modulators, we will produce different frequencies, all right, using different inputs, all right, channel A and channel B, and then we will use hybrid network to mix these two signals, and then try to get the sidebands side by side from different channels A and B, and lastly it will become like this. Okay, I don't want to explain detail on this. If you interested to know about this in detail, you may refer to any electronic communications books. It actually explain it in detail under single sideband system. Okay, for the receivers, I think in last chapter, chapter 5, we learned about reception. Okay, and in the reception or in a receiver, especially in AM, we know that we need to uses 5 stages in order to extract the information signal from the carrier. To recap, what is that 5 stages? First, we need to have the RF stages, and then the converter stages. The third one is RF stages. The fourth one is the detector stages, and lastly the audio stages. So if we see on the single sideband receiver over here, it actually use almost similar okay, stages. But for this slide, I only show you um, um, the until IF stage. Okay, but for this receiver, this is actually for non-coherent BFO SSB receiver. So BFO is actually bit frequency oscillator, all right, that is used in SSB receiver. So if you see from this block diagram, once the modulated signal is received by the antenna, it will pass through the RF stage, and then we have the RF mixer, and then you will produce the IF. And in the IF, different with the one that we have learned in chapter 5, it also has another one more mixer to use in the receiver, especially for the SSB signal. Okay, so for this one, the we have what we call as bit frequency oscillator here, and we always want to tune the frequency of BFO to be equal with the frequency or IF carrier. Okay. Okay. This is for the non-coherent. For the coherent BFO SSB receiver, a little bit different with the non-coherent one. All right. It's actually identical but a little bit different, because why? We try to combine the oscillators that we use in the RF stage and also the IF stage into one. All right. So we call it as carrier recovery and frequency synthesizer. So this actually will give the frequency of RFLO as well as BFO to the IF and RF mixer. Okay, so this is how we design the receiver. I also don't want to explain so detailed, because we have learned about reception in the chapter 5. It's just that the components inside a block diagram for the single sideband and also double sideband literally a little bit different, but still using the same stages that a receiver need to have. Okay. So I think that's it for chapter 6. For the next video, I will explain the next chapter, chapter 7, that explain about frequency modulation and phase modulation, that also known as angle modulations. Okay, all right, thank you.